Hi, welcome back to the channel and this walkthrough video on the January 2023 P2 paper. Without further ado, let's get started. Okay, so question 1 here, we've got a trapezium rule question. Now don't forget, trapezium rule is in your formula booklet. Just popped it there on the screen, so there's no kind of excuses with I can't remember it. It's just in your formula booklet. So we're going to start with part A, and it's nicely done. It's given us all the values in the table, so we don't need to work anything out, just straight into the formula. So here we are looking at our f of x. We're integrating it between 1 and minus 1. Okay, so that is our f of x there. Now, if you look at your tables, it's going up in halves, 0.5, so we know h equals 0.5 from that table. Okay, and then if you look at your table, you know, this is your y0, y1, y2, y3 and y4. Okay, so it's got 4 strips, which of course is 5 values. You know, that'll be the first, then you have second, third, fourth, fifth, creating 4 different trapeziums. So all I'm going to do now is plug these values in. So we've got half times that 0.5, and then we've got our, now I like to do it a little bit different to this. I like to put them in kind of order, my y0 in the beginning and my y, well, my last y at the end, but it doesn't really matter. So we got 2.287 plus 2 lots of 4.470 plus 6.719 plus 7.291 plus 2.834. Okay, obviously I could put this and this both at the front just like they do there, if it's any easier for you. Now I'm going to show you, so we've got 10.52025. It says give your answer to 2 decimal places, so 10.52 there. So that's part A, very easily done. Now part B, part 1, we want to integrate between 1 and minus 1 f of x minus 2. So this I can split up into 2 integrations, or 2 integrals. So first it is f of x minus 2. So we've got the first part, obviously this we've already got up here, isn't it? So that is 10.52 minus, and then this is going to integrate to 2x between 1 and minus 1. So we got 10.52 minus, now if I substitute the 1 in, I would have 2. And actually I'm just going to put a bracket here so I don't mess up my signs. And then when I substitute the minus 1 in, so I'd be taking away minus 2. So I've got 10.52 minus, and this is 2 plus 2, so it's 4. So I'm taking away 4. So this gives me 6.52. Okay, so that's B part 1, and then B part 2, I'm going to put this in blue writing just so that you can follow it a little bit better, not confusing it with the other working out on the page. So we got this between 1 and minus 1, and it's f of x minus 2. Now, this just shifts the whole thing to the right by 2. So it's not going to change the actual sign. You know, for example, this would essentially be, well, I don't know how to describe it, but everything is just going to be moved 2 to the right. So this is going to be, instead of minus 1, it'll sit at 1, and this one will sit at 3, but that whole shape is moved to the right. So this doesn't change. So this is just 10.52. And I think you could just state that, you know, you could say, you know, same as A, or doesn't change, or something like that if you want to as well. But yeah, it stays the same. Okay, question 2. Looks like could be a bit of differentiation and stuff here. So what have we got? Width is x, length is 3x, and the height is h, and the volume is there, 972. So let's start with the volume. Length times width times height. So we get 3x squared h, and that equals 972. So we've got a little bit of information there. Anyway, I've just put that up there for now. Let's look at what it says for part A. Show that the surface area of the brick is given by this formula. Right, so surface area, they're using S, so let's just use S. So we've got essentially each part. So like this face is x times by the height here. So it's x h. This is 3x h. You know, you get the 3x by h. And this top one is x by 3x. So 3x squared. So those are my faces. And I'm going to have 2 lots of each. So xh plus 3x squared plus 3xh. So expanding this is 2xh plus 6x squared plus 6xh. Now, obviously, if I look at this, there's no h's in here. So that's where I've got to use this information here. So this. So what I want to do is make this a h equals 972 over 3x squared h. Now 972, looking at the digits, they total, well, 18 if you just look at the digits, so it should be divisible by 3, and it is, so 324. So that is 324 over x squared. Why have I written h? Yeah, over x squared. My apologies there. So now we can substitute that in. So 2x times 324 over x squared plus 6 x squared plus 6x times 324 for x squared. So one of the x's are cancelled there, and one of these x's will cancel there. That leaves me with, so I've got times in by 2, now we get 648 over x plus 6x squared plus, and then 6 times 324 will be 1944 over x. Now those parts we can obviously simplify. So we get 6x squared plus 2592 over x. And that is what we needed, so as required there. Okay, obviously you can use QED and you don't even need to say anything at all. Right, part B. So part B, if I just add this, and it wants us to find ds by dx. So this is quite straightforward. You know, really you're just looking at 6x squared plus 2592x to the minus 1. Yeah, that's what you're thinking of. So we get 12x minus 2592x to the minus 2, or 12x minus 2592 over x squared. Okay, and then part C, hence, so it means using our answer to from the previous part, find the value of x for which s is stationary. So if it's stationary, it's going to have a gradient of 0, isn't it? So it is when ds by dx equals 0. So I'm just going to make a little bit more room. So as we said, we've got ds by dx equals 0. Therefore, 12x minus 2592 over x squared equals 0. So 12x equals 2592 over x squared. Multiply by x squared and divide by the 12, so we'll get x cubed on the left hand side and 216 on the right hand side, and then taking the cube root we get x equals 6. So next we've got part D. We need to find d2s by dx squared. So d2s by dx squared. So that will give us 12. It's going to go to plus now. Obviously we're multiplying by the minus 2 there. So 2592 times 2, 5184. 5184 x to the minus 3. Okay, and then it says hence show that the value of x found in part C gives us the minimum. So substituting x equals 6 in, we get d2s by dx squared is equal to 12 plus 5184 over 6 cubed, which is 36 there. But you don't need to actually work this value out because it's quite obvious there. You got 12 plus a positive number. You could jump straight to writing that d2s by dx squared is greater than 0. Therefore x equals 6 is a minimum. Okay, so just remember that. Final step, hence find the minimum surface area of the brick. So that is just using the original formula. So s equals 6x squared plus 2592 over x. X equals 6, so s equals 6 times 6 squared plus 2592 over 6. And then we're just popping this in our calculator. So it's effectively 6 cubed, isn't it? Plus 2592 over 6. And we get 648 centimeters squared. and that's the minimum area there, or minimum surface area. So we've got a binomial expansion. Find the first 4 terms in ascending powers. So f of x, so 2 to the power 7, that'll be all there is in the first one. Then we've got our 7(1) for our NCR, 2 to the power 6, and then kx over 8, which would be to the power 1. Obviously don't need to put in the power 1, but I'll just pop it in there. So that's the second term. Then we've got 7c2, 2 to the power 5, kx over 8 squared. So here now we've got 1, 2, 3 terms, one more, 7, 3, that's 2 to the power 4, kx over 8 cubed. Okay, next thing I need to do is just, well, simplify it, sort it all out. So 2 to the power 7 is 128. And we've got 7c1, which is 7, multiplied by 2 to the power 6 is 448. And then we're obviously dividing by 8, so that's 56. So 56kx plus, so you got 7c2, which is 21, multiplied by 2 to the power 5. That gives me 672, and then I'm dividing by 8 squared this time. So that is 21 over 2 k squared x squared. And then I've got 7c3, which is 35, times 2 to the power 4. And then I'm dividing by 8 cubed. And that gives me 35 over 32 k cubed x cubed. And obviously this would carry on, but we just needed the first 4 terms. Now, given that in the binomial expansion of f of x, the coefficients of x, x squared and x cubed, so we got 56, 21 over 2 and 35 over 32, are the first 3 terms of an arithmetic progression. Now, I have to be careful here that I'm not focused on just those numbers, because k is also a number, isn't it? So k will be part of it. So my first 3 terms of my arithmetic progression would be 56k, 21 over 2k squared, and 35 over 32k cubed. Now, if you think for me to go here to here, that difference should be a common difference, and here to here should be the same. So if I did like the second term take away the first term, it should equal the third term take away the second term. Yeah, so 21, sorry, I'm start writing in red then. 21 over 2k squared minus 56k is equal to 35 over 32k cubed minus 21 over 2k squared. Okay, so just factorize in both sides. So you've got k here, 21 over 2k minus 56, and here we have a k squared outside, 35 over 32 minus 21 over 2, and this one has a k in it. So immediately now I can say, right, I can definitely divide 1k from both sides, can't I? And then once I've done that, then I'm going to work out my simplify. And I suppose I didn't really need to factorize to do this. I could have just took 1k out of each one, you know. So instead of doing this, just switch to my red pen, I could have just done divided by 1k. So that's left me, you know, the 21 over 2k minus 56 equals 35 over 32k squared minus 21 over 2k. So as we can see, we've basically got a quadratic, haven't we? So 35 over 32k squared. Now if I take away 21 over 2k from both sides, I get 21k, and then I add the 56. So there we have a quadratic. Now I could just put this now straight into formula. So if I was going to go straight into the formula to solve, I could put it into my calculator to help me solve it, but just remember this is not acceptable if you're just going to use your calculator. Also, the way I'm going to do it is I'm not going to jump into the formula. You can, I would probably, if I was in the exam, under exam conditions and under the time, I'd probably chuck it straight in the formula at this point. But 35, 21 and 56, 7 goes into each of those. So I'm going to divide by 7, so 5 over 32k squared minus 3k plus 8. And then I'm going to multiply by 32. So I'm going to pop it up here. So I get 0 equals 5k squared minus 96k plus 256. And that should now 5 minus 96, 256. So I'm just going to pop that in my calculator and I can see, right, we've got a 5k and a k minus 16 and minus 16. So let's just check it. So 5k squared, 5 times the minus 16 is 80, and the minus 16 there is the minus 96. And 16 squared is 256, so minus 16 times minus 16 is 256. So we get 5k minus 16 equals 0, so k equals 16 over 5. And then k minus 16 equals 0, so k equals 16. Okay, and it's just find possible values, so that's it. I will say that if you are curious, I do talk about what I'm doing in my calculator sometimes, but I do have another camera coming for a bit of a different setup, so I'm hoping in future videos I'll be able to have my calculator on the screen at the same time for questions like this. So fingers crossed. Don't know why they do this in questions. Why are these in part 1 and part 2? Why not just use A and B? Very strange, isn't it? If someone knows why they do that, just let me know in the comments. Right, let's get started. So, using laws of logs, solve this equation. So we've got part 1, log base 3 4x plus 2 equals log base 3 5x plus 7. So what I can do here is with this 2, there's a few different ways you could solve this, but I'll go with how I tend to solve it. I would multiply this by log to the base 3 times 3, because this is just 1. And then what I can do is go log 3 of 4x plus log 3 of 3 squared equals log 3 of 5x plus 7. Now I can put these two together by multiplying, because this is an add, so we get log 3, and it's 3 squared, so that's 9 times by 4x, so that is now 36x is equal to log 3 5x plus 7. That means 36x must be equal to 5x plus 7. 31x equals 7. X equals 7 over 31. An alternative way would be if I wrote it, say, like this. So that would give me, on the left side anyway, 5x plus 7 over 4x and the 2, and then I can use my rule to switch, you know, when you switch between the logs and the powers, the indices. So that would give me that this 5x plus 7 over 4 is equal to, and I think the 3 across there, and that becomes the power, so 3 squared. Oops, sorry, there's an x on the bottom. And then this is basically the same thing now, isn't it? Multiplied by the 4, so we get 36x, oh sorry, multiply by the 4x, 36x equals 5x plus 7, down to x equals 7 over 31. So that is another method, but it's not my preferred one. I always forget when you switch between those two rules. It's the very first rule of logs you learn. I often, because I don't use it very often, I often make mistakes. That's just me personally, because I never really like that rule, so I don't really use it. There's always another way. Right, let's look at part 2. So we've got here a sum and a sum. Right, given that equals that, find y in terms of a, give your answer in the simplest form. So let's start with on the left. So it's a sum between 1 and 2. There is our r. So r equals 1 and r equals 2. So we'd have on the left log a y plus log a y squared, because that's the sum, the first one and the second term, just substituting 1 and 2 in. And here we're going to do the same, substitute 1 and 2 in, but r is on the outside. So we've got log a y plus log a y squared. Okay, so that's my first part of this expansion. Now, as you can see, we've got a log a y and a log a y. Those two will cancel with each other. Just one take with the other one. And then we want to bring this power down. So we've got 2 log a y minus, and I'm going to bring this over, log a y squared, and that equals 0. Now, basically what we've got here is like 2x minus minus x squared, if you will. Yeah, so like I could factorize out the x, and that would be 2 and x, and that x is just that log y to the base a. Okay, so that's how you're thinking of it. So this would give me log y to the base a brackets 2 minus log y to the base a equals 0. So now we have log y to the base a equals 0, or 2 minus log y to the base a equals 0. Now, this is impossible, so we've just got that one answer. So we've got log y to the base a equals 2. So y equals a squared. Using the rule I hate, getting rid of the way I remember this is that one stays there and the a goes across and pushes the 2 up. That's just how I remember it. But there we are. That's question 4 done. Okay, we've got a function here, p and q constants, and p is greater than 0. Doesn't say anything but q. Given that x minus 3 is a factor, okay, so if it's a factor, it means if I substitute in 3, it should equal 0. So like f of 3 equals 0. So f of 3 is 3 cubed plus p plus 3 times 3 squared minus 3 plus q equals 0. So 27 plus, so we've got 9p plus 27 minus 3 plus q. So 27 and 27 is 54. Just check my calculator. Yeah, 54 minus 3 is 51. So we've got 9p plus q minus 51 equals 0. Sorry, plus 51 equals 0. And 9p plus q equals negative 51 as required there. Given also that when f of x is divided by x plus p, the remainder is 9. Show that. So part B, so f of minus p, so we substitute minus p in, and that's going to give me 9. Okay, so f of minus p is minus p cubed plus p plus 3 times minus p squared minus p plus q equals 9. So we've got minus p cubed plus minus p squared is obviously just p squared times p, so that's p cubed, and times the 3 is 3p squared, minus p is plus p plus q equals 9. Now the p cubes are going to just cancel with each other, leaving with 3p squared plus p plus q equals 9. And to get in the same form, so 3p squared plus p plus q minus 9 equals 0. So that's the first two parts. It's just 4 marks, so nothing too much to do. So there we have the two of them. Hence, find the values of p and q. Even if you couldn't do these, you could certainly do this bit. It's not a problem. So 2 equations, 2 unknowns. This one's a quadratic, so you want to substitute from this one in. Okay, so I'm going to just create a little bit more room. Well, created lots of room. So this is going to be my equation 1. This one's my equation 2. So let's go from 1. Now I think it's easier to make it a q equals. So q equals minus 51 minus 9p. And let's sub that into equation 2. So 3p squared plus p plus minus 51 minus 9p minus 9 equals 0. So we've got now 3p squared plus p minus 51 minus 9p minus 9 equals 0. I don't know why I got rid of the brackets just by effectively writing the same, but I did anyway. So we got 3p squared minus 8p, and then minus 51 minus 9 is minus 60. So let's go to a couple of brackets. Obviously just complete the square, use your calculator to help you, whatever it takes. So we're looking at 10 and 6. Plus and minus, I think. 3p squared minus 18 plus 10 gives me minus 8, and 10 times minus 6 is minus 60. So there we have it. So p equals, so we got 3p equals minus 10, p equals minus 10 over 3, p equals 6. It told me that p was positive here, so we can eliminate that one. Now I've got my answer. I want to sub p equals 6 into, you always want to substitute it into the linear one, the easier of the two, so into equation 1 in this case. So we've got 9 times p plus q equals negative 51. So 9 times 6 is 50. I don't know why I use the calculator. It's late. I'm doing this late, aren't I? Not thinking. So 54 plus q equals minus 51. So q equals, now we're taking away 54, so q equals negative 105. Okay, part D. So this is what we've got. The f of x now, if we put the values in at the top, I'll do this in red so they stand out. Our f of x now equals x cubed plus, now p is 6, isn't it? So 9x squared minus x minus 105. So that is my equation. So what I've got here is x cubed plus 9x squared minus x minus 105 equals x minus 3, and the g of x would be an ax squared plus bx plus c. That's what I'm looking at. So I'm going to do this by inspection. So if I look at the x cubes, we've got 1 on the right and we've got 8 on the left. So a is 1. If I look at the x squareds, I've got 9 on the right, and then on the left I've got x times bx, that'll be bx squared. I've also got minus 3 times ax squared, so minus 3a. A is just 1, so b here is 12. And then for the final one, I can see that minus 3 times c is equal to 105 there. So that's looking at the constants. So minus 105 equals minus 3c. So I just want to divide 105 by 3, and that gives me 35. So c equals 35. Okay, so what I've got here for this now is, I'll write it all back out actually. So x cubed, let's write f of x equals x minus 3, and then it is x squared plus 12x plus 35. Okay, and there you have it. Now we're at the kind of halfway mark in this video. So just a reminder, if you haven't subscribed to my channel, please do so. As pretty much everyone on YouTube always says, oh, it helps me out, but it really does. And, you know, give me a thumbs up if you find any part of this video useful. Let's get on to the next question. Okay, here we have equation of a circle, and we need to find the coordinates of the center and the radius. So we really need to have it in the form of x minus a squared plus y minus b squared equals r squared, where a, b are the center and obviously r is the radius. That is our aim. So let's take the equation. So x squared plus 8x plus y squared minus 4y. So just putting the x's together and the y's together. And then I'm just going to complete the square for both of them. So x plus 4 all squared minus, and then 4 squared is 16. And then we have y minus 2 all squared minus, and then 2 squared is 4. So we have x plus 4 squared plus y minus 2 squared equals minus 16, and minus 4 is obviously minus 20, and when I take it to the other side it will be positive 20. So we have now the coordinates of the center is minus 4, 2, and then the exact radius would be root 20, which you could write as 2 root 5. Okay, now next part we have the point P lies on C, given that the tangent to C at P has this equation. So that should mean that this and this will intersect at point P. Well, you know, it certainly just touches at point P. So what I probably need to do here is I need to substitute this equation into here so that I can work out one of my values, either x or y, and then I can use that value then to find the other value. So let's put b. So I'm going to rearrange this one. So x equals minus 2y minus 10. And I'm going to put that in that top equation. So I'm replacing my x. So minus 2y minus 10 squared plus y squared plus 8x plus 8 times 2y minus 10 minus 4y equals 0. Yeah, so just replacing my x in both of these terms. So I want to first expand this bracket. So minus 2y squared would be 4y squared. Minus 2y times minus 10, so minus 20y doubled, so plus 20y plus 40y plus 100 plus y squared minus 16y minus 80 and minus 4y. So let's sort this out. We've got 5y squared, yeah, then 40y, and then we've got 16 and 4, so that's minus 20 plus 40, so it's just plus 20y, and then I've got 100 minus 80 is plus 20, and I can divide by 5, so we get 4y plus 4. Okay, then we have, because obviously we're only going to get one value, this is just going to be the same thing, isn't it? So we've got y plus 2 squared, basically, y plus 2. Yeah, y squared, 2y is 4y, and that's 4. So I can write it like that, or I can put it like that. But either way, y equals -2. Now I have that, I can look at x equals -2y minus 10. So -2 times -2 and minus 10. So -2 times -2 is 4. 4 minus 10 is -6. So our coordinates are -6, -2. Now, final step is to find the equation of the normal. Give your answer in the form y equals mx plus c. So this is now part C. Well, first what I'll do is I want to rearrange this equation. So 2y would be equal to -x minus 10. Y equals -1/2 x minus 5. Okay, so that means that this gradient is -1/2. So gradient of normal will be 2. Yeah, flip and change the sign. So we've got the gradient of the normal. We know the point at P is -6, -2. So it should be quite straightforward from here. So we've got y minus -2 equals 2 times x minus -6. So y plus 2 equals 2x plus 12. Y equals 2x plus 10. I don't think that was too difficult to do. It's quite a nice, straightforward question. Right, let's move on to the next one. Here we have a geometric series. First term is a, common ratio is r is greater than 0. So we have the third term, which would be ar squared, and that is equal to 20. And the fifth term, ar to the power 4, and that is 12.8. So we need to show that r equals 0.8. So if I take my fifth term, so ar to the power 4, which is 12.8, and I'm going to divide by my third term. So I'm going to divide by ar squared, and that would be divided by 20. So if we look here, the a's will cancel, and 2 r's will go with 2 from the top. So we're left here with r squared equals, and this is 0.64 as a decimal. Therefore r equals 0.8, because if I square root that, I would get plus or minus 0.8, but as r is greater than 0. Yeah, so sometimes I might have put the plus and the minus in first and then put the positive, but I'll just put it with r greater than 0 next to it. Now part B is hence find the value of a. So I'll start with a third term, a times 0.8 squared is equal to 20. So a is equal to 20 divided by the 0.8, which is squared 0.64. And that is 31.25. So part C, we're looking at a sum. So the sum to n terms is a brackets 1 minus r to the n over 1 minus r. And what we want is when this is greater than 156. So let's see, we want A is 31.25, 1 minus 0.8 to the power n over 1 minus 0.8, and that to be greater than 156. And obviously we've got to find n. So first I'm just going to divide by 31.25. So I've got 1 minus 0.8 to the power n over 0.2, isn't it? 1 minus 0.8. And then 156 divided by 31.25 is 4.992. Then I want to multiply by the 0.2. So you get 1 minus 0.8 to the power n is greater than 0.9984. I want to get the 0.8 on its own. So you think I'm going to have 1 minus 0.9984 on this side, and then I'd have 0.8 to the power n on the other side. This positive is what I want. So 1 minus this is 0.0016. So that's where we're up to right now. I'm just going to make a little bit of room. Okay, that's better. Now what I'm going to do is I'm going to take logs. So logs both sides. It doesn't matter which one you take, which base. Then bring my n down. Now, log of a number between 1 and 0 will give me a negative value. Okay, any log of a number between 1 and 0. So if I'm dividing by this, it's going to be divided by a negative number, so my sign will flip. So I get log of 0.0016 divided by log of 0.8. The sign changes, and there is my n. So n is greater than 28.85. Therefore, n equals 29. Okay, because we wanted the smallest possible value of n. Just a point, you can do it from this point just by rearranging your logs, the format, from the power to the log. But I find doing it this way is just a little bit more straightforward and less confusing. Now, this tells you to show all stages of your working. So you do have to be a little bit careful. But let's start off with the first. So I've got 5 sine 3x plus 0.1 plus 2 equals 0. Now, if you get a question like this with that angle in brackets, and this is going to be in radians, so make sure you put your calculator in radians. So if we got something like this, what I want to do is just make a single letter. So it's going to be theta equals 3x plus 0.1. So now we have a new equation, 5 sine theta plus 2 equals 0. And we also have a new range. Here's my range there. Yeah. So if you think about it, let's start with x is pi and minus pi by 2. That's what it's between. 3x is between 3 pi and minus, let's see, 3 over 2 pi. Yeah, multiplying by 3. And then we've got to add the 0.1. and that becomes 3 pi plus 0.1 minus 3 over 2 pi plus 0.1. So in other words, now this bit here, that is become my theta. So this is the range that I'm going to be looking for. Now let's go back to our equation. So 5 sine theta equals minus 2 sine theta equals minus 2 over 5. So now we want to find theta. So if I put this into my calculator, I would get this value here. Well, actually this to 3 significant figures. But what I like to do is put the positive version in, because what that'll do is that'll give you the acute angle, and that's what you're going to need. So positive, so I do like 2/5 rather than minus 2/5, and in this case with sine it's not a problem, it will just give me the positive version of this, and then I store that in my calculator. What I should do next now is using the cast diagram. Each of these angles is 0.412 radians. And there is my cast. It's sine but negative. So that's going to be in, I'll put this in red, this section and this section. Okay, now we've got to go positive round to 3 pi plus 0.1. So all the way round to 2 pi, and then we go round to 3 pi plus a little bit, which it won't make another angle, but that's what we've got. So we've got, 0.412, we put that in there, 0.412. It's in the sine one as well, but I don't really need it. So as I go through my angles now in the positive direction, I've got, that's pi, isn't it? So we start at 0, go in this way, we get to pi, we carry around, that'll be 2 pi there, and we carry around and it'll be 3 pi. So I get pi plus 0.412. So pi plus 0.412. It's one angle. I get 2 pi minus 0.412. And then I get basically 3 pi plus 0.412. But this last one, we just need to think, right, 3 pi plus 0.1, 3 pi plus, that's a 0.4, isn't it? So it's not going to be within my range. So I don't need this last angle. So I basically don't need that. So I'll just rewrite this one a little bit better. So we've got, what was it, 2 pi minus 0.412. So just 2 angles when we go in the positive direction. Now we need to go in the negative direction. Now, looking in the negative direction, again we're going to start at 0, but we're going to go in this way. And this will be minus pi by 2. This is minus pi. This is minus 3 pi by 2. Okay, so that's what I'm doing. I'm going in this direction. Now, I don't need to worry about this, so we've got a little bit, 3 pi plus 2 plus 0.1, so it would be slightly in this section, but the 0.1 is not going to be anywhere near this angle. Okay, so I don't really need to do anything with that. But if you wanted to make sure, you could do the minus pi minus this angle, and you can see, but we haven't got anything in that section, we haven't got anything in this section, so that is kind of irrelevant in this case. But if you had a case where we had an angle here, you could take the minus pi plus, minus your angle here to see if it still fell within the region. Anyway, let's get back onto where we are. So we're going to get 2 angles, and the 2 angles are going to be minus 0.412, and the second angle is going to be minus pi plus 0.412. Now, some of you might be asking, why is it plus? It's just simply, you can always check it out using your calculator to help, but if I'm at minus pi here, because this direction is all negative, into this section would be getting a larger negative value, so that's why you'd have minus pi minus or something. And then going back into this section, you'd have a smaller negative number, which is why you're kind of adding that. So minus pi plus this angle. Okay, hopefully that makes sense. So there I've got 1, 2, 3, 4 angles, and now I just need to kind of work them all out, because it just says give your answer in radians to 2 decimal places. Okay, so we've got theta equals. Now, this is obviously not the full answer, because this is just going to be for theta, and we need it in terms of x. So we are going to have to do a little bit of rearranging using this. Okay, but each of my angles are, if I write them all down, so we've got 1, 2, 3, 4. So I've got, first one would be pi plus my angle, which is alpha, so that is 3.55, and I'll go to an extra decimal place. Okay, so these are the 3 decimal places. Now I want my x values down here, so I'll work these out as I go. Now to work it out is simple. I've got the theta, so then I want to get the x, so I'll take away 0.1 and divide by 3. So minus 0.1 divided by 3. So my x value is 1.15. Now I'll go on to the next one here. So I've got 2 pi minus alpha, because I stored this angle here as alpha. Yeah, I stored it as A. I should say, not alpha. So that is 5.872, and then I do the same again. So minus 0.1 divided by 3, and that's 1.92. And I do them, this part, together in pairs, because it's easier than working all these out and then working all of these out. So then I've got minus 0.412. So that's just my A. So minus 0.1 divided by 3, and that is minus 0.10. Oh, that's just it, 10. And then the final answer is minus pi plus my A, so minus 2.730, and it's minus 0.1 divided by 3, and that's minus 0.94. Those are to 2 decimal places. Apologies, I've actually made a little mistake here. This one, just realized I actually put positive 0.412 in my calculator, not minus. So putting it back in again, so minus my A, and then minus 0.1 divided by 3, so it's 0.17, minus 0.17. So a little silly mistake there from me. Just shows you that obviously when I can make them, just making a video, anyone can make one in the kind of pressures of the exam. Okay, so just be careful there. But those are the 4 answers, and ultimately I feel like this is a fair bit of work just for 4 marks, It's a little bit of a disappointing question, I think. Right, let's go on to the second part. So we have 2 tan theta sine theta equals 5 plus cos theta. Right, it's just a single theta, and we've just got this, and now we need to make sure we put our calculator back into degree mode as well. So I think how I will approach this by changing the tan into sine over cos. And then that gives me, 2 sine squared, obviously with the sine times sine. I will multiply through by the cos, so multiply by the cos, so that my other side will become 5 cos theta plus cos squared theta. Okay, so multiplying through by cos, and that will leave me with just the sine squared on the left and that on the right. Now we've got this in terms of sine and cos. We need to replace one of them. Obviously I could replace either, but I can only replace the squared one. So if I replace this for a sine squared, it won't leave me any way of changing that one. So I want to replace this one for cos squared. So it becomes 1 minus cos squared theta. And that's obviously from sine squared plus cos squared equals 1. Now what I need to do is expand my brackets, and then it's going to be to simplify. Okay. So I've ended up with, take the 2 cos squared over to the right, and we get 3 cos squared theta plus 5 cos theta minus 2, and that is equal to 0. Now if I'm going to do my brackets, it's just going to be a 3 cos theta and a cos theta, and we're going to multiply to make 2 is quite easy. It's just a 1 and a 2, and it's got to be this way around, 2 and the 1 there. So 3 times 2 is going to be 6, so we want that positive, we want that negative. So 3 cos squared, 6 cos minus 1 cos is 5 cos, and minus 2. So here now we have 3 cos theta minus 1 equals 0, or cos theta plus 2 equals 0. So cos theta equals 1/3. Cos theta here equals minus 2. Now obviously cos is between 1 and minus 1, so this is not possible. So the cos theta equals 1/3 is the one that I am focusing on. So I'll go to my calculator, do inverse cos of 1/3, and I will get the angle 70 point. It's to 1 decimal place it 1 set, so 70.5 degrees. Now I'm going to have a second angle, aren't I? Because we got between 0 and 360. So set up my cast. 70.5 is the angle. That's obviously starting at 0, and this is positive. So it's going to be where cos is positive, so here and here. So you think we're going round in this direction, 180 there, and back round to 360 there. Okay, so we want this angle here, and this is going to be 360 minus my theta. So 360 minus theta, yeah, my 70.5. So I get 70.5, and then 360 minus this answer gives me 289.5. And there we have my 2 answers. And despite being worth more marks than the first part of the question, this was far quicker to work out, wasn't it, to get its 5 marks. And I think quite easy really, but let me know what you think of this question, whether it was easy for you. Okay, so we have curve C with equation here. This is curve C there. And we want to find that the coordinates are D, so it's just going to be 5, isn't it? It's going to cross out 5 there because that's the equation. So when x equals 0, isn't it? So A is 0, 5. Nothing too difficult. Now let's move on. So the curve C intersects with line L at the points E and F. E and F. Okay, that's L. That's this one, isn't it? Y equals 2. Okay, I should find the coordinates of E, or the x coordinate of E and the x coordinate of F. So again, then part B. So we got y equals x squared minus 4x plus 5, and we know now this is at y equals 2. So 2 equals x squared minus 4x plus 5. So x squared minus 4x plus 3. So let's factorize it. X, 1 and a 3, both negative, isn't it? So x squared minus 3 minus 1 is minus 4, and minus times a minus is positive 3. So I have x equals 1, x equals 3. So it asks me for the x coordinate of E and the x coordinate of F. So that is E and that is F there. And that is it for part B. So it says the shaded, so that region R1, that's here, and region R2, this one. And it wants area of R1 over R2 equals K, and we have to find K. So what we need to do here is basically find these two areas. So I'll just put these values onto the diagram. That's 1 and that's 3 there. And that there is 5. So what I need to do here for R1, I want to integrate between this curve and this line, and obviously between 0 and 1 there, because 0 and 1, the area under this curve, so give me all the way down to the bottom, and then I just need to take away this area underneath. Okay, so I mean that's obviously like that, 0, 2 there. So I can do it two ways. I can find the area under this, and then I can take away kind of, let me see, I can say, right, take away this area, this square, or I can kind of just do it in one go. So I'll just rub that out, but yeah, I can just do it in one go. So what I'm going to do is I'm going to integrate between 1 and 0. And it's this equation, so x squared minus 4x plus 5 minus y equals 2, so it's 2. Okay, so all I'm doing here is this equation take away this equation, and that'll give me the area between the two of them. Okay, so it's effectively integrating x, that's terrible right turns, x squared minus 4x plus 3, and that will give me x cubed over 3 minus 4x squared over 2 plus 3x, and it's between 0 and 1, of course. The 2 will cancel there, and that'll make it slightly simpler. So I've got, if I substitute 1 in, 1/3 minus 2 lots of 1 plus, and that's squared, 3 lots of 1. minus, and then when I substitute 0 in, they're all going to be 0. And that gives me 4/3. Now, I'm going to do the same kind of thing now, but for the second one. However, before I work out the second one, I really need to work out this here, this line. Now, if I was working them out, actually, I could take a bit of a shortcut here, because here we've got a triangle. So I could work out the area of this triangle and take away R1 from it. So that might be one nice thing. If you think about it, we've got this kind of triangle here. We know that's 3, 0 in the x's, because that's 0, 2, isn't it? 3, 2. And then this is like 0, 5. So it has height 3. It has base 3. And that is a right angle triangle, isn't it? This has an area of 9/2. Therefore, R2 is equal to 9/2 minus R1. So 9/2 minus R1. And that gives me 19/6. And then I could go ahead and work out what K is. So K is R1 over R2, so 4/3 over 19/6, which is 8/19. Now, the only problem is it does say using algebraic integration. So we have used some algebraic integration, but not all. Now, I've just checked the mark scheme just off camera there, and it is perfectly fine to find R2 with another method, provided you've got a correct method for R1. So if you found R1 with integration correctly, using this method or using integrating this one and then subtracting that rectangle there, then and you get 4/3, then you can use that to find your answer to part B for R2. What I'll do now is I'll just go back to this point, and I'll show you how to find R2 using integration, in case you want to do it just purely with integration. Okay, so R2, again, we're going to integrate this one between 0 and 3. Okay, now to do this method, what I really need is this df, the equation of that line. So I'm just going to pop it up. I'm going to do this in blue just so you can see. Well, no, I'll use green. It's okay. So we're looking at an equation that goes from D to F, that line. Okay, so we know the coordinates. D is 0, 5, and F is 3, 2. So the gradient is difference in the y's, 5 minus 2, over difference in the x's, 0 minus 3. So we get 3 over -3, which is -1. So y equals minus x plus 5. We don't really need to solve anything. We know it's going to see its c value is the 5 there. Okay, so that's that equation. Now I can use that one in my integration. So I'm going to have x squared minus 4. Sorry, I'm going to start again. I'm not going to have that. I'm going to have minus x plus 5 minus x squared minus 4x plus 5. Because what I'm doing is I'm finding the area under this line, and subtracting it from the area under this curve. Okay, now this will give me the areas between these two, but it'll give me the areas between these two all the way down to this point. So it'll also include this area here. So it's a little bit of an issue. So actually I won't be able to make it in one go like this. What I need to do is a little bit of change. So I'll just put this green in here. And what I need to do then is, there's no way of doing it integration in one go. So I can work out this like split into these two sections here. So if I just show you, what I'm actually going to do is work it out not between 0 and 3, but between 0 and 1. So what that's going to do is going to mean that I find the area here. And then I'd have to add on that triangle at the end. So let me just get rid of some of this. So what I would need to do is go there plus, and then we got half times 2, and also I'd have to work out that height there as well, because it was y equals minus x plus 5 when x was 1. It means that that height there is 4. Now this means that this here coordinate is 1, 4, but if you think this coordinate is 1, 2, so the height of that triangle is 2. So half times 2 is just 2. So there we are now. So I'm integrating between 1 and 0. I'm going to simplify this now. So 5, if I look at the 5 first, 5 take away 5 is 0. I haven't got to worry about that. Minus x minus 4x is minus 1x plus 4x, so 3x. And that's just minus x squared. So integrating that, and then I've got to add 2 on. So this becomes 3x over 2 squared minus x cubed over 3 between 1 and 0 plus 2. So it gives me 3 over 2 minus 1/3. When I substitute 0 and I get just 0, and then I'm adding 2 on. And that gives me 19 over 6. So, I mean, you can't just integrate it simply. So, personally, I wouldn't do this method. I would have done the way I did it the first time, you know. But there is another option for you, and I'm sure there are more options than the ones I've shown you. And obviously just finishing off the question with this just the same way as before. Okay, right, let's get on to the final question. So we've got a proof question here, which is like partly done or partially done. So you can see here we've considered n equals 3k, and we've shown that that is not divisible by 3. But obviously n equals 3k doesn't include every possible number, does it? So we have to consider a couple more cases. Now, what I would like to consider would be 3k plus 1 and n equals 3k minus 1. That way, if we look at the 3k, we've got one above and one below, so that would now cover every possible integer, wouldn't it? Because whatever value of k is, yeah, it would give me every possible number with the plus 1 and the minus 1. You could also do this with, like, say, plus 1 and plus 2, for example, or -1 and -2. And then all we're going to do is the same kind of thing. So we have, 2n squared plus n plus 1 would become, we got 2 times 3k plus 1 squared plus 3k plus 1 plus 1. So that is 2 times, so 9k squared plus 6k plus 1 has 3k plus 2. 18k squared plus 12k plus 2, 3k plus 2. So we got 18k squared plus 15k plus 4. So you can see here, if I look at 18k plus 15k plus 3 plus 1, as this is divisible by 3. So 3 lots of 9k plus 5k, sorry, this should be squared there, plus 1 plus 1. So not divisible by 3. And then we do the same for 3k minus 1. So 2n squared plus 2n plus 1. So 2 lots of 3k minus 1, almost wrote plus 1 there, plus 3k minus 1 plus 1. So because of the minus, and basically I'm just going to jump a couple of steps here, we get 18k squared. We get minus 12k this time, just because it's like minus 6k comes out and then times by 2, and then we still get plus 2, then we get plus 3k, and that's it, isn't it? Because there's the ones at the end, the minus 1 and the plus 1 do cancel. So I end up with 18k minus 9k plus 2. That's it simplified, but to get my divisible by 3, I need to change the 2 into something equivalent. So I want to make it 3 minus 1, because 2 is the same as 3 minus 1, and 3 is obviously divisible by 2. And then I can say, right, 3 times 6k, sorry, squared, I missed out the squares again, minus 3k plus 1 minus 1, not divisible by 3. Alternatively, at this point I could have instead just written, right, 3 times 6k squared minus 3k plus 2, and then just left my not divisible by 3, because it obviously isn't. So then we can say, hence 2n squared plus 2n plus 1 is not divisible by 3. And that's all there is to it. I really hope that you get some use out of this video. Don't forget to like, share with your friends, and comment and let me know how you find this paper. See you next time.